Hi all, welcome to Try Technologies and also DevOps Factory. Whoever have not subscribed our channel, please subscribe our channel and also share with your friends and family so that it will be very helpful for the people. And don't forget to subscribe DevOps Factory also, which we are doing all the videos in English. Okay, so this video also it will be in English. So because we have already done shell scripting, so shell scripting is already there in Telugu. Okay, so you guys can go and watch the shell scripting playlist, which is in Try Technologies for Telugu. And if you want to get into the English, you can go to any one of the channels, DevOps Factory or Try Technologies. So here I wanted to start shell scripting so that people, like a lot of our folks are asking to do the shell scripting again from basics to advanced. So I thought of doing it from basics to advanced. It will take maybe 1 to 2 months. Okay, so because I wanted to do this every a day for 30 minutes or so. So I'll try to make like 30 minutes, 40, whatever it is, but I'll try to make it. Okay, so 20 to 40 minutes, whatever timeline it might be. Okay, so I'll try to do it every day. Okay, so you guys can come and watch every day for the bash from basics to advanced. I'll try to finish it off as soon as possible. And also we'll see the basic command or basic command line instead of commands, what I will see. So we'll see what is Linux command line and also bash or shell scripting. Okay, so first of all, like a lot of people are getting confused with bash or shell. Okay, so we'll talk about shells. Okay, so what are the shells we have? Okay, so what are the Linux shells we have? What exactly that shells will do, and what exactly the work of individual shell. Okay, so that will definitely look into that because like Linux command line and shells, like it's a good idea to get the understand of what Linux is first. Okay, so whenever we are going into the shells, you should know what is Linux, where it has come from, how that works. Okay, so we'll try to do all that stuff in this first session. Then we'll go to the shell. Okay, so then we'll start with the shell. Okay, so if you want to get into what is Linux, okay, so how Linux is defined and what exactly the Linux kernel looks like. So I'll just give that video which is already been done by us. Okay, so we have already done that in the Linux session. So I'll just move that. Okay, so I'll just give that information here. Okay, so that you guys can get into the idea of what Linux is. Okay, and what all the shells is about. Okay, so directly we'll jump into what is shell. Okay, so how you access the command line or how you reaching the CLI via Linux console terminals or via GUI emulators, and how you are using genome terminals or xterm terminals. Okay, so we'll see all that stuff. So generally, like when we are talking about the Linux, it is like being there from long back. Okay, so it is there from 1980s. Okay, so whenever we are talking about Linux in the olden days, it is always system administrators or programmers and system users all like call like something called Linux console terminal. Okay, so or entering shell commands and viewing text output. So how they used to do? They used to do using a CLI, that is command line interface, or they used to call it as console terminal. Okay, so this is also called as console terminal. So in one of the in some of the series, still when you go into the Ubuntu box, you still see it as a terminal. Okay, so generally like how you will be reaching to this command line. Okay, so whenever we don't have this graphical desktops, now we all seeing all the graphical desktop GUI desktops, right now whenever you go for CentOS, Ubuntu, whatever the flavor you are going for the Linux, you will see all the graphical interfaces desktops, right? So when there was no GUI or when there was no graphical user interfaces, the only way to interact with the Linux machine was through text command line. Okay, so that is text CLI, that is text command line interface. So this is what, and this is which provided by the shell. Okay, so how this text command line interface is provided, this is provided by the shell. Okay, so this is called shell, like you can say like this is what we call it as a shell. Okay, so the CLI, like it allows you to text input only, with text input only. Okay, so you can do only text input, and you can also get the output as text. Okay, so that is what we can have. And also you can also have graphical output. We'll see that. Okay, so you can also graphical output. Okay, so whenever you are inserting the text commands. Okay, so with these restrictions, okay, so generally when we have these restrictions, so output devices, okay, so not very much into the scope of what we are doing right now when we are talking about GUI. Okay, so you just needed only a simple terminal to interact with the Linux, Unix, or Linux machines, or Unix systems. Okay, so it is just like a monitor or a keyboard. Okay, so like for example, if I have a machine, I used to we used to connect a monitor, okay, so and also a keyboard to this monitor, and just run like via your communication cable. We used to run all the commands. Okay, so this is used to be happen, like even now when we are talking about servers, it will be same. Okay, but when we are talking about GUI, whenever we are talking about desktops, we have all these GUIs. You can see whatever the information, whatever the resources you want to see, you can see in the GUI. Okay, so how these console terminals are. Okay, so how this works. Okay, so one way to get to the CLI is to access the Linux system via the text mode, like I said. Okay, so this will be providing you like a simple shell CLI. So when I open a CLI, it is just a simple shell CLI where you can enter all your text commands. Okay, so let me open and show you that. Most of you guys already know what is CLI. Okay, so now I'll just show you like how. If you see here, open in terminal. Okay, so this is what it's used to be. Okay, so this is, we call it as a Linux console. Okay, so because this is what we used to call it as a Linux console, because it used to be hardwired console terminal. So where you can directly connect your keyboard to the monitor, and you can check like what is exact, like you can pass all your commands. Okay, so this is how it has been. Okay, but how it is now. Okay, so when we are talking about graphical terminals, okay, so that is the alternative use, like when we are saying graphical terminals. Okay, so that is the alternative to using a virtual console terminal. Okay, so this is nothing but terminal emulation package. Okay, so from within the Linux graphical desktop environment. Okay, so if you see here, I'm into the Linux graphical desktop environment. Okay, so out of that, I'm just opening my terminal emulation package. Okay, so this is the terminal emulation package which simulates working on a console terminal, but this is happening within the graphical window. But when we are talking of olden days, okay, so we don't used to have this graphical window. Okay, so we used to have only this console. Okay, or you can say only this terminal. Okay, so now in the graphical mode, we can see all this stuff. Okay, so because when we are calling things, okay, so and also when we are saying accessing CLI via Linux console terminal. Okay, so these all terms. Okay, so when we are talking about Linux console terminals, or graphical terminals, okay, so or CLI. Okay, so these are all the things where now it means you will be working only through graphical user interfaces to connect to the servers. When I'm talking about servers, okay, so just don't confuse. We have two types. Okay, so one is desktop, one is a server. Okay, so when I wanted to work from my laptop, or when I wanted to work from my desktop, okay, so I now within the office. Okay, so when you go into the office, you will get this. Okay, so because you should have your desktop working to connect to these servers. Okay, so the servers are, again, those are not GUI. Okay, so again, they are only terminals. Okay, so they are only terminals. But when you want to connect to those servers, to the terminals, you can do it from the GUI, nothing but your graphical user interfaces, using the terminals inside the graphical user interfaces. Okay, so this is how we can do, this is how we can connect. Okay, so we have different types of terminals, like I said. Okay, so we have genome terminal, we have terminal to connect to the CLI, and we have different terminals like what we say, the menu bars. Okay, so you can go to the menu bar and you can see what type of terminals you are having. Okay, so these are all the stuffs. Okay, so and also you can go and work with the console terminal emulator, that is KONSOLE. Okay, so you can also download KONSOLE console terminal, and also you can get the console from your menu bars. Okay, so when you install, you can see that in your menu bars. Okay, so these are all the Linux shells, or you can say like these are all the CLIs or the patterns where you can go and communicate with your servers. Okay, so that is how it works. Okay, so this is just a basic idea of how we are interacting with the application, or how we are interacting with the Linux system using the text-based CLIs. And also I've already explained what all the shells we have in the session. Okay, so I've already attached the session. Okay, so that already have like what kind of shells we have, how to connect with those shells, how to move within those shells, like how to switch your shells. Okay, so now we see like what is basic bash shell commands. Okay, so we'll see basic bash shell commands, like how you will be interacting with the shell, or how you will be using the bash manual, how you will be traversing the file system, or how you list files or directories, how you manage your files and directories, and how you will be viewing the content. Okay, so we'll see all that stuff in this session. Okay, so the default shell, okay, so used in many of the distributions is the GNU bash shell. Okay, so bash shell I've already explained, that is a born again shell. Okay, so that is the major default shell which is used by many of your distributors. Okay, so nothing but your Linux distributors. So we'll see all that commands with like all that stuff in the bash shell. So we'll be working with the bash shell here. Okay, so when we are talking about shell, okay, so the GNU bash shell is nothing but a program. So it's a program that provides interactive access to your Linux machines. Okay, so what is exactly the bash shell is? Okay, so bash or GNU bash. Okay, so you can say GNU bash shell is nothing but a program. Okay, so this is a program that provides interactive access to your Linux system. So if you want to have an interaction with your Linux system, what is the program you are using? You are using shell. Okay, so this is basic interview question. A lot of people are going, like many of the people are asking nowadays when you are going for the interviews, like what exactly this shell is. Okay, so when you are saying a shell, what is shell? Shell is a program which is used to interact with your Linux system, and also it runs as a regular program, and it's normally starts whenever your user logs into the terminal. Okay, so whenever I log into a terminal, this shell, okay, so or this bash is automatically getting started. Okay, so how, like for example, if you file contains, or if for example if I go to /etc or /etc password file, okay, so it contains a list of all system user accounts, and also it will have all the basic configuration information about your every user. Okay, so for example, if I go and search for, I'll just show you that. Okay, so I just wanted to interact with /etc and I'll say /passwd. Okay, so when I do this, okay, so you can see here. Okay, so this every entry have 7 data fields. Okay, so and also it is separated with a colon. Every field is separated with a colon. So the system what is using the data in these fields to assign specific features to the user, right? So why I'm showing this to you? Okay, so you guys might have got some picture when I have opened this etc/password, right? So most of these entries, okay, so we'll discuss in the file permissions, but for now when you see this, okay, so when you see this, the last field, okay, so the last field shows you the user shell program. Okay, so what is this user is using? Okay, so when you see root, so it specifies the user shell user shell program. So if you see here for root, it is the bin bash. Okay, so we are logged in as a user. Okay, so we are logged in as a root. Okay, so it is showing as a bin bash. And also if you scroll down, so we have also logged in as a tri-tree technology. So what is the tri-tree technologies? Bash here, like program here for the user bin bash. Okay, so it is nothing but it is running under the shell called bash. Okay, so simple, like the sample entries of the user, like if you see bin bash, okay, so or you can see user has been no login. Okay, so we'll talk about all this stuff, but whenever you want to see what kind of the shell you are using for that particular user, you can go and check in the /etc/passwd. password. Okay, so this is automatically starts at the login. Okay, so whether a shell command line interface is presented depends on which login method is used. It totally starts automatically. Okay, so whenever you log in into the terminal, it just starts the shell automatically. Okay, so now we'll just see how we can use this shell prompt. Okay, so now whenever we are starting a terminal, okay, so whenever we are starting a terminal emulation package, or whenever we are logging into the Linux console, so you get access to this shell CLI prompt. Okay, so this prompt is your gateway to the shell. Okay, let me go to my home directory. Okay, so now, okay, so you will get access to the shell CLI prompt using this virtual console. Okay, so the default program or the default prompt symbol for the bash shell is $sign. Okay, so if you are seeing here, so what is the default prompt symbol you will get? Just open this. Okay, so the default prompt symbol for your bash is $sign. Okay, so if you see here, you are already seeing here, this is the $sign. Okay, so this symbol indicates that the shell is waiting for you to enter any text. Okay, so one more thing is different Linux distributors using different formats for the prompt. Okay, so this is your Linux Ubuntu system. Okay, so the prompt looks like this. Okay, so your prompt will be looking like this when you are logging into your Ubuntu system, and also when you logging into the CentOS system, it might be a different prompt. Okay, so that I'll show you. Okay, so this is my CentOS box. Okay, so if I right click on this and if I open my terminal, okay, so if you see here, it is just showing try tree at the local host. Okay, and also it is showing my dollar prompt. Okay, so what exactly this try tree is? Okay, so try tree is nothing but my username, and also this is my machine name. Okay, so this is my machine name. My machine name is showing as localhost, and also if I go to this desktop, Ubuntu desktop, my machine name is showing as Ubuntu, and also my user is try tree tech. Okay, so this is a major thing. Like we can also see a lot of things on the shell prompt. Okay, so we'll discuss that later. Okay, so when you are saying like how you are interacting with the bash manual. Okay, so we need to interact with the bash manual. Nothing but every command has a manual page, nothing but a information page. So how will you use that page? Okay, so most Linux distributions include that manual online page where you can get all the information on your shell commands or the Linux command. So how you can do that? The command is nothing but man. Okay, so the command called man. Okay, so if you see here, what manual page do you want? For example, try man managers. Okay, so I'll just say man hostname. Okay, so now if I see here, for example, if I show you like if I have clicked it man hostname, so it is giving all the information. Okay, so hostname command, it gives a description about that. Okay, so and also it is giving me synopsis like what all the characters or what all the arguments I can use, and what is the host, what exactly this command is used for. Okay, so it's used to display the system's DNS name and to display or set its host name or NS domain name, and also you can set the name, you can get the name. Okay, you can get the FQDN, and also you can see what all the options you can use. Okay, so you will see like who are the authors. Okay, so who are maintaining these. Okay, so we'll see all this information with the manual pages. Okay, so majorly this manual pages section have the name, synopsis, configuration, description. Okay, so like I've just shown you, right? Okay, so all that stuff you can check into in the manual pages. Okay, so why these manual pages are very important? Okay, so whenever you are running, okay, so whenever you do whenever you run something, okay, so or whenever you forgot something, okay, so that these manual pages will give you lot of information. And also in manual pages there is always some section numbers. Okay, so for example, if I'm coming out of this, okay, so and also if I want to see overview of what exactly the hostname command does, I'll just say man 7 hostname. Okay, so now if you see here, okay, so it just gives a description. Okay, so whole description of what exactly, what is the overview and all that stuff. Okay, but it's not giving me the entire thing. Okay, so when I search for man hostname, it was giving entire thing. Okay, but it is not giving entire thing right now. It's just giving me the specific things. Okay, so nothing but it's just giving me the overview of what hostname is all about. Okay, and also if you want to go for the system calls, I can go for manual man to hostname. Okay, so if there are any system calls, okay, so it just says manual entry for hostname, means no manual entry for number 2. And also if I want to see any executable program is having on this, okay, so you can see these are all the executable programs, nothing but what all the attributes you can use to check or to use in the manual pages. So every number has its own value, own representation. Okay, so 1 is nothing but your executable programs. Okay, and 2 is nothing but your system calls. 3 is for library calls. 4 is for special files. Okay, so this is how it just categorized. Okay, so if you want to see that, okay, so manual page in Linux. Okay, manual page numberings. Okay, so manual page numbering in Linux. Okay, I'm not sure if someone has given this. This is all what is the number. Okay. Okay, it should show all the numbers, but yeah, I'm not seeing that. Anyway, like every number, okay, so we have 9 numbers. Okay, so it has its own section numbers. Okay, so or I'll say Linux manual pages section numbers. Okay, I hope someone gives manual page section numbers. Oops. Okay, so yeah, if you see here, okay, so it just shows like what all the numbers you can give here. Okay, so if you give 6, it give games. Okay, 5 file formats, 4 special files, 3 is library calls. Okay, so 2 is your system calls, and 1 is executable programs or commands available to the user, and also 7 is your overview. Okay, so word process package, so you can see the overview of what. Okay, and 8 is nothing but your super user and system administration commands. Okay, so you can see what all the system admin commands you can use with the manual pages. So I'll just show you an example with that manual with 8. I'll say hostname, so it will just say that there is no nothing with this. I mean, your PS also have nothing with this. Okay, see, you might have, you might not have. Okay, so for example, system CPL might have. Okay, so okay, so service have that. Okay, so if you see here, these are the administrator things. Okay, so if you go service hyphen status, all it just shows what all the things you can search. Okay, and also where the files are sitting, etc initd. Okay, so these are all stuff like you can go and get when you are writing the shell programs or the bash programs. That is very important that you know what exact number is. Okay, instead of searching every bit of that what do you say, the command. Okay, so if I say man service, it will show a huge page, but if you want to categorize within the section, you can do that also. Okay, so that will be very helpful for you. Okay, so that is how it is. Okay, so that is how you can get all the manual information of the command from your Linux prompts. Okay, so then we'll go and check all these file systems. Okay, now we'll talk a lot about file systems. When you log into your system and when you are reaching your shell command, you usually placed into one of the directories. Okay, so what is the directories you will be going into this? Okay, so when you see here, you will be landed into the, okay, so you have landed into the home directory, whereas same thing happens with your CentOS also. Okay, so if I just say pwd, so it just landed me into my home directory. Okay, so most of the time you want to explore like other areas in the Linux system, right? So besides, it's just not only the home directory. So we'll see like what are the Linux file systems we have and how we can access them. Okay, so whenever we are talking about the Linux file system, the root system or the root file system is always your slash directory. Okay, so when I am talking about the directories, file systems. Okay, so this slash. Okay, so everything starts with the slash. Okay, so slash is your root directory. Okay, so from there we have lot of file systems, that is bin. You can go with slash boot. We have slash dev, slash etc, slash home, slash var, slash etc, tmp. Okay, so there are a lot of things. Okay, but whenever we are logging in, where it is landing us, it is landing us in our home directory. Okay, so there are, like, if you want to go and check what are the file systems exactly in within the Linux system, you guys can go and check in the slash directory. That is nothing but if I go into slash and if I say ls. Okay, so if you see here, I have bin, boot, dev, home, etc, cd-rom, I have media, lib, lost, found, mnt, opt, root, proc. Okay, so there's a lot of things. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so what exactly we look in this? Okay, so we'll just go into the CentOS. Okay, so in CentOS, okay, so you can see there's a difference in CentOS. Okay, so when you go into the Ubuntu, you have swap file. Okay, so you have library 32, library x32, library 64. Okay, so but here you have only lib 64. Okay, and also you don't have swaps file here. Okay, so swap file here. Okay, so this is like, some of the things will be different, but most of the things will be common when you are talking about bin, boot, etc, dev, home, media, mnt, opt, proc, root. Okay, sbin and usr, var, tmp. Okay, so these are all the basic your basic file system hierarchy. Okay, so this is how you can go and check like what exactly the file system hierarchy looks like in your machine. Okay, and also whenever we are traversing the directories, nothing but whenever we are moving between the directories, we need to use the command called cd. Okay, so if you are not at all having an hands-on on Linux, okay, so you might be wondering like what is this cd? Cd is nothing but a change directory. If you want to change any directory, for example, if I want to move to any directory here, okay, so for example, if I want to move to the slash tmp, I'll just do cd slash tmp, nothing but I'm just giving my destination directory of like where I wanted to move. Okay, so there is two types of directories, that is, one is relative path, one is absolute path. Whenever I'm saying a relative path, okay, so for example, if I want to go into any file, okay, so for example, if I want to go into the var log, okay, so I cannot say like log, cd log, I cannot go there. Okay, so I need to give an absolute path. Okay, so I'll give a path like I'll just give like slash var and I'll say slash log. Okay, so now I can move into that directly. Okay, so you need to give absolute path. If I'm saying a relative path, so whatever it's there within this cd log. Okay, so if I want to go into the vi messages, okay, so I can go into the vi messages. Okay, so that is how it is a relative path. But if I want to go into the absolute path, I need to give the entire file system directory reference. Okay, otherwise I cannot move into the entire file system directory reference. Okay, so this is also, I'll just give you I've already done this. Okay, so I'll just copy the video here. Okay, I'll attach that video here. Okay, this first video might be a bigger video. Okay, so when we compare with the other videos, okay, so every day 20 minutes I said. Okay, so every day 20 or 30 minutes, but I will be attaching the video, the what do you say, introduction of what shells, and also a video of all these basic commands. Okay, so that you guys will have a clear picture of how it is done. Okay, so and I'll give you overall overview of file system. Okay, so I'm not going to give an entire in-depth thing, but I'll just give you an overview of file systems, or how will you list the file systems, how you copy, how you move all that stuff in the next session. Okay, so that will be an overview. Okay, but before going for this entire course, make sure that you already watched RHCSA in our program, or else you can go and watch the Linux series in the DevOps Factory channel. So where we have started the Linux also. Okay, so stay tuned and hope you guys will enjoy this series. Okay, so hope you will get a good hands-on on Bash or shell scripting. Thanks for watching this video and have a great day. Bye. Hi all, welcome to DevOps Factory. Please like our channel and don't forget to subscribe our channel. Okay, so there are almost 479 subscribers. Make it more subscribers so that we can do a lot of videos in this channel also. We are doing all the videos in English in this channel. So whoever are watching our Tri-Tree Technologies channel, please come and subscribe here so that you will get a lot of content here, so that you guys can easily get into the organizations. So what we are going to do further, like in this channel, I've already told you, like we'll give all the overview of DevOps, how it is works, like how it works, and how good it is in the market, and how people are using that in the real time. Okay, so everything what we are doing is based on the real time only. So this video is the same thing. Like we'll talk about mastering of Linux administration. Okay, so that is the agenda of starting this. Okay, so not sure like how many days it will take, but definitely we'll try to close this as soon as possible. Okay, and also a lot of people are asking me to do it on a notepad kind of. Okay, so they are asking me to type it on a notepad, but it's not like when I had a poll, it was very few people who asked me to do it on a notepad. Okay, so everyone is comfortable with what we are doing. Okay, with the whiteboard. Okay, so we continue with the whiteboard. So what exactly is Linux administration right now? There are huge number of openings in the Linux administration. So when I'm saying huge number of openings, like it is always uh, known thing that Linux is the one which will have openings regular. It's not that we don't have Linux openings, or we never had a Linux openings. Like since from last 14-15 years, whenever we check on Linux, you will see the openings on Linux. Okay, so that is how Linux is being in the market. Okay, so we'll see how that works, and how you need to prepare for the Linux administration and all that stuff. Okay, so this is on DevOps Factory. This won't be coming in the Tri-Tree Technologies because we already have a huge number of Linux in Tri-Tree Technologies. Okay, so we'll see Linux admins. Okay, and also we'll try to do a master of Linux admin. Okay, so like from basics, we'll see from basics to advanced, and how we can do this, and how people are doing it in the real time. That is a major thing. Okay, so when we are talking about basic functions or basic administration of Linux, okay, so most of you guys know what is Linux. Okay, so history of Linux and all that stuff. So Linux is an operating system which has been used extensively now. Like when you are talking about comparison with Windows, Linux is extensively used in real time. So I would say like 90% or 95% of the environments are running on Linux. Okay, so it is like a storm in the market right now, and also uh, Linux is a one which is like used in everything. Like whenever you're running your Linux servers in mobile phones, you're running your Linux in IoT devices, in all the servers which are running up and running all your apps. Okay, so there's lot of things happening in the real time which is being used by your Linux operating system, and most of the things like it's embedded Linux software operating in phones, even your utilities like refrigerators, whatever it is, like whatever things you take, it is everywhere. It is Linux. Okay, so that is the reason why it's very huge, and it's very popular right now in the market, and you have very good number of jobs when you compare with other technologies also. So it is not like you have to go only for DevOps or middleware or business intelligence, Tableau or data science, artificial intelligence. Whatever you go, wherever you go, this is a basic. Okay, so without knowing the Linux, you cannot master in any one of these technologies. Okay, so it's always better like you start your career with Linux, you know, do know what is Linux. And also there will be like might be whenever you are learning or you want to become a Linux administration or administrator, it is always like you will be in a panic state, like whether it will be good for me, because whenever you start, okay, so whenever you start Linux administration, it is like you feel it like a very complex topic, or whenever you open your command line interface, you will see like, oh, okay, so whether I remember this when I'm going forward, because when you start learning and if you see typing the commands on your CLI, that is command line interface, you will feel very easy, like, okay, so this is very easy, like we can do it. But when you skip the practice, okay, so without practice you cannot be perfect in Linux. Whenever you skip the practice, it is like you don't know anything. For example, if you are starting to learn Linux today and you have done a good work for 20 days and you stop for 10 days, you don't, like, you will forget everything, like what happened. So it should be like you have to make sure that how regularly you are practicing it. Okay, so that is the main thing, like when you are learning the Linux. So we'll see like what is Linux. Okay, so what exactly the Linux is and how it has been designed and how it is. Okay, so like if you have never came across Linux or if you have never worked in the Linux, so you might be confused as why there are so many different versions. Like when you see, there will lot of versions in Linux are available, and also you might have heard about various distributions, or you can say some of the people will call it as distributions, and some of the people call it as live DVDs and GNU. Okay, so when looking into this Linux packages, I may have some confusion between this. Okay, so what all this stuff and why there is a lot of distributors coming in the Linux. So this is we'll explain you like how this has came up and why there are so many distributions. Okay, so but before that we'll see like what exactly or what is very important when you are going for the Linux machines. So there is always something when you are going for the Linux to learn. First, there are like four parts. Okay, so there are four main parts. Okay, so there are four main parts that makes your Linux system. So knowing what is Linux, knowing what is Linux system is very, very important. Okay, so what are all these four parts? Okay, so when we are talking about these four parts, okay, so I'll just open my notepad, okay, so that I can also share this notepad if possible. Okay, so first one is Linux kernel. Okay, we'll see what is Linux kernel. Then we can see what is GNU utilities. Then we'll see a user interface. Okay, and then we'll see what is an application software. Okay, so these are the four major main parts which makes your Linux. Okay, so each of these four parts has a specific role to play in the Linux systems, and also we'll see a basic diagram of how these uh, Linux paths have been placed. Okay, so let me open something called draw.io. You might already know this. Okay, so why draw.io? Draw.io is something to draw. Okay, so it will make you feel good. Let's see. Okay. Okay, so what I'll do is I'll pick one box here. Okay, so this is my hardware. Okay, so whenever we do something, okay, so there should be a hardware, right? This is my computer hardware. So we talked about something called Linux kernel. Okay, so where Linux kernel sits. Okay, so Linux kernel is the one which sits on top of this. So I could say like this is a Linux kernel. So this is a very important part which is communicating with your, okay, this is the one which is communicating with your hardware. Okay, so this is how it looks. Okay, okay, don't take much time. Okay, so now here you have a computer hardware. On top of that, you will be having your Linux kernel. Okay, and where you will have your GNU utilities. Okay, so here you can go with your GNU utilities. We'll talk about that, what exactly GNU and all that stuff, but how it looks like. Okay, so this is how it looks. Okay, so here you will have your GNU utilities. Okay, and where is your user interface, like how you will connect with the Linux kernel. Okay, so using GNU, and also one more thing is your user interface. Okay, so your user interface is also one which comes and connects with your Linux kernel. Okay, then on top of this you will have your application software. Right here you will have your application software. So this is your user interface, this is your application software. Okay, again, like it will communicate with this, right, and these two will communicate, and also here with the application software you will be communicating with your user interface only. Okay, so this is how it looks like. Okay, so you will have your computer hardware. On top of this, you will be having Linux kernel. So how you will communicate with your Linux kernel? You will connect with your user interface and also GNU utilities, and your user interface, like your application software, will be sitting on top of your user interface. Okay. So now if you look into the Linux kernel, okay, so Linux kernel is the one which is a core of your Linux system. Okay, so kernel is one which is a core of your Linux system, and kernel is the one which controls all of your hardware and software on the computer system, which is also helping you to allocate your hardware when necessary and executing softwares when required. Okay, so that is a major role of the Linux kernel. So if someone asks you what the kernel is doing here, kernel is your core system. Linux system core is your kernel, and also it controls all your hardware and software components, and also it is the one which is helping you to allocate the hardware when necessary, and also this is the one which is executing your software whenever it is required. And also uh, you might have heard about someone. Okay, so when you are talking about history of the Linux, okay, so we know this part. Okay, so now you know how Linux kernel is there. Okay, so whenever you are into the Linux, okay, so you might have heard a person's name called Linus Torvald. Okay, so Linus Torvald is the person. So he is the one who is responsible for creating the first Linux kernel system, or you can say first Linux kernel software. Okay, so he is Linus. So Linus Torvald is the one who created the first Linux kernel software while he was like, it is a very young age actually, when he was student in one of the universities. So actually he was doing some research and he wanted to copy, like he got this Linux thing from the Unix systems. Okay, so Unix system is one which was very popular operating systems at that point of time. Okay, so from Unix, what he has done, he has extracted the code, or he copied the Unix system code, and because it's an open source, okay, so you can get that code, like at that point of time it was available openly, so that he picked it from Unix and he has created something called Linux. And also after developing this Linux kernel, he released into the internet community. Okay, so what do you mean by internet community? Like he wanted people to come and suggest, or he wanted people to come and give suggestions on how this is working and how what improvements is required. Okay, so all this stuff required, so that he made it more like an open source, so that people can come and people can check on the operating system or a kernel, and they started suggesting some improvements. And also it's a you can call it as a revolution. Okay, so in the computer operating systems, like when Linus started this, it is like a revolution. And also he was getting some suggestions from all the students and also professional programmers. Okay, so that that is where he was moved Linux forward. Okay, so that is how he made Linux very extensively popular. And also it is like allowing anyone to change the programming code in the kernel. So it is not restricted to someone, because he has openly put that in the internet, and he asked for all the suggestions. Okay, so there it is always like he allowed anyone to change the programming code in the kernel. Okay, so where uh, it also made some complexity. Okay, so where to simplify things, so he acted as a central point of all the improvement suggestions. Okay, so instead of making everything on the fly, so what he has done is he made himself as a center point where he can improve and where he can get all the suggestions, and he was improving it. And also it was his decision whether to incorporate a suggestion into in the kernel or not. Okay, so if someone wants to someone had a suggestion, and if they want to put that in the kernel, okay, so he is the one who decided, like he's the deciding factor. Okay, so to put that in the kernel or not. And also same concept. Okay, so still in place when you are talking about Linux kernel code till date. Okay, so but like till date it's the same concept, but we don't have Linus who is controlling the kernel code now, because there are team of developers which are working on these tasks. Okay, so this is the background of how Linus brought Linux into the picture. Okay, and also the kernel is normally primarily responsible for four main functions. Okay, so what are those four main functions? Okay, so if I open this notepad again, okay, so we are talking about kernel. Okay, kernel have four main functions. Okay, so what are all these four main functions? One is your system memory management, right? Next one is your software program management, and the next one is hardware management, and the next one is file system management. Okay, so these four are very main important functions of your kernel. Okay, so primarily these are the responsible for whatever we are doing into the kernel. Okay, so when we are talking about system memory management, so what do you mean by system memory management? So system memory management is one of the primary functions of your operating system kernel, like management, memory management. Okay, so this is very important. Okay, so this is your primary function of the operating system kernel. And also kernel manages the physical memory available on the server, and it can also create a managed virtual memory or memory that does not actually exist. What do you mean by virtual memory which is not exist? We'll see that what exactly it does, but who is responsible for managing that? Your kernel. Okay, so Linux kernel is the one which is responsible to manage all your memory. Okay, so it might be a physical, it might be a virtual memory. Okay, so whatever the memory it is. And also it does something by using your space in the sense your hard disk. So what is that means? Whenever you are using a hard disk space to create a memory, that we are calling it as a swap space, right? So if someone asks you like what is a swap space is nothing but like we are using the space on the hard disk to create a memory, that is a swap space. And this kernel swaps the contents of virtual memory locations back and forth. Okay, so it might bring down or it might bring up. Okay, so the swap space, and also it is actually with respect to your physical memory. Okay, so what I mean? So if I go back to my whiteboard, okay, so if you see here, this is my virtual memory. Okay, so out of this virtual memory, okay, so in between what I will have my kernel in place, right? So this is my kernel. So this kernel is managing all your virtual memory, and also there will be our physical, right? So there will be our physical memory, which is managed by kernel itself. And also we have already talked about something called swap memory, right? That is our swap space. So this is also managed by kernel. Okay, so but swap space is sitting on your hard disk. Okay, so nothing but from your hard disk you are getting some space. Out of that you are creating a swap space. Okay, so these memory locations actually grouped into blocks. Okay, so all these memory locations are grouped into blocks like this. Okay, so these blocks are also called as pages. Okay, so we are calling these blocks as pages, and also this kernel locates each page of memory either in the physical memory or in the swap memory. And also the kernel then maintains a table of memory pages, like it will indicate which page are in the physical memory and which pages are in the swapped out to disk. Okay, so it will have a table, it will maintain a table to know that which page is in which memory. And also kernel is the one which keeps track of which memory pages are in use, and also it will automatically copies memory pages that have not been accessed for a period of time. Okay, so that is called as swapping out. That is what I told you, like there is always a swap in and swap out, right? There will be swap in and swap out. Okay, so whenever, okay, so whenever like uh, there is something called memory pages which are not being used or not being accessed for a period of time, so we are doing a swap out. Nothing but kernel is doing your swap out. Okay, so whenever you log in into your machine, okay, so how will you look that? Okay, so we like when I'm talking about memory, right? So how will you look into that when you log in into your Linux machine? Okay, so how you check that, how much memory is left in your machine? Okay, so let me log into one of the Linux boxes and show you that. Okay, so let me log in. Okay, so this is my CentOS box. Okay, so we'll see all these commands what we are doing, but yeah. So how you check memory, or from your command prompt, you need to run something called free. Okay, so if you type free, okay, so the output from the free command, right, shows the total amount of physical memory installed on the system. Okay, so this is the total memory installed on your machine, as well as the amount of swap space. Okay, so what exactly is configured. Okay, so it is also showing the swap, what is the swap space which is configured on your machine, right? So this is the free command, like to just, it just provides you an overview of the memory. Okay, what is exactly in your Linux machine. And also you can go for, I can say free -g also. Okay, so you can see like total memory is 1 GB for this virtual machine, and also 2 GB for the swap. Okay, so this is how we configure this machine. And also if you want to know more information, okay, so by seeing like what exactly happening, if you want to do the detailed information of memory, you can go for cat proc memory info. Okay, mem info. If you see this, it will give you a detailed notes of, or detailed table of what exactly it is doing. Okay, so how much memory is free, or how much it is available, what is used for cache. Okay, so what is inactive, what is active. Okay, so you can see all this detailed information using /proc/meminfo. Okay, so where how this is happening, this is what kernel continuously updates. Okay, so who is doing this? Kernel is the one who is responsible for continuously updating this memory info file, so that it will show exactly what is going on in the memory at this or at that moment of time. Okay, so at this moment of time, what is happening, if you want to see in the memory, you can go for the memory info. Okay, so this is about your memory. Okay, so the next one is, we talked about software management, software program management. Okay, so what do you mean by software program management? So this Linux operating system calls a running program. What do you mean by running program? So running program is nothing but, let me write this. Running program is nothing but a process. Okay, so a process is the one which runs in the foreground, and also it displays the output, like what exactly, how exactly it is running. And also one more important thing is, this process can also run in the background. Okay, so it can run in foreground, and also it can run in the background, like you don't know like what is happening, but it will be running behind the scenes. Okay, so who is controlling this process? Again, the kernel is the one who controls how the Linux system manages all the processes running on the system. Okay, so it is always a kernel's job who is controlling all these processes. And also kernel creates the first process. Whenever you start your machine, kernel starts its first process. So what is the first process is called as? It is called as init process. Okay, so we call it as init process. That is init process. So to start all other processes in the system, kernel starts its first process called init. Okay, so without init you cannot start any other processes on the system. And also when the kernel starts, it loads the init process into the virtual memory. Okay, so we have already discussed about memory, right? So it will always loads init process in the virtual memory as it starts each additional process. Like it gives it a unique area, nothing but unique page in virtual memory to store that data and to store the code that the process uses. So whatever the process you are starting, it will store that in the unique area of the virtual memory. And also there are two different types of init processes which are available in Linux. Okay, so the most popular are like sys init, and one more is systemd. Okay, so these two are the init processes or the initializing methods which are very popular right now in the Linux world. Okay, so when we are talking about sysvinit, like sysvinit is the one which is also an initial method. Okay, but this is a original method used by Linux and was used from the Unix machines. Okay, so this was extracted like in the beginning of the days. Okay, so this is a original method of starting your or initializing methods. Okay, so right now this method. Okay, so when you're talking about sysvinit, not most of the most of the distributions are not using. Okay, so but you can still find them in the older versions of Linux, but it is not being used in many distributions right now. So many distributions right now are using the systemd. So systemd is also an initialization method which was created in 2010. Okay, and it has become more popular initializing and process management, which is used by many distributors right now. Okay, so that is your systemd. Okay, so and also the systemd init method, right? So it has some run levels. We used to call it as some run levels. So what are all the run levels when we are talking about run levels? Okay, so there will be some numbers. Okay, so like init 0, and you say init1, init2. Okay, like we have till init6. Okay, so what all these do? Okay, so when I execute something called init0, it will shut down my machine. When I run init1, it will go into single user mode, and init2 it will go into multi-user mode. So like this, like we have different options for all the inits, but the mostly used. Okay, so when you're practicing, or you can go for the init0 to shut down your machine, and also you can go for init6 to reboot your machine. Okay, so if you want to reboot your machine, okay, so you can run init6. We'll try whether it works here. Okay, so I'll just do init6. If you see here, it is just restarting my CentOS machine. Okay, so this is how you can run your initialization methods. And also if you go into /etc init tab, it will define all your run levels. Okay, so what are the run levels, and also which process that starts for specific run levels also defined in /etc rc.d directory. Okay, so if I type something called run level, it will show like, okay, so we can view like what current run level it is using. Okay, like if I do enter, okay, so if I go into vi etc init init tab, okay, so you can here you can see like few of the run levels, but all are commented, but yeah, you can enable them. And also if I go back and say run level, okay, so it is showing N5, nothing but I'm in multi-user mode with GUI available. Okay, so because my GUI is available, and also I'm in multi-user mode, so that is how it is shows like N5. N5 is nothing but I'm using a multi-user mode with GUI, right? So this is my machine. You are seeing like this is the GUI, and also I'm using a multi-user mode. So the system initialization method is like which is being used extensively right now because of the ability to start process based on different events, like when the system boots, or when the particular hardware device is connected, when the service is started, or when a network connection is established, or when a timer has expired. Okay, so with respect to all this, we can see like what exactly and how it, like system initializes with respect to these processes. Okay, so how you do or how you work on it. Okay, and also we can also say like that which systemd method determines what process to run, and also these events are called as unit files. Okay, we are calling it as unit files. This is not a command, I'm just giving you like, okay, so we are calling it, we will be calling it as unit file. So this each unit file defines the program to start with the specific events. Okay, so when there are any specific events, these are the unit files which will help you to start. And also there is one program. Okay, so what is the program called? Okay, so there is a one program that is systemctl. So the systemctl is the program which allows you to start and stop and list the unit files which are currently running on the system. Okay, so that is what a unit file is, nothing but a process, like what process is linked with the event, that event is called as a unit file. Okay, so how you can see that using a program called systemctl. So this systemd method always groups unit files together into a targets. Okay, so if I run something called systemctl get hyphen default, okay, get hyphen default, oops, okay, so it says like graphical dot target, nothing but the graphical dot target is a target defines a process to start when a multi-user graphical environment is running. Okay, so it is same like your run level file. Okay, so nothing but your init, sorry, whenever I ran run level, right? So it is N5. The same thing we are looking from systemctl process. Okay. So and also you can see what are all the processes running in the machine using a command called psax. Okay, so psax is a command. Okay, so if you see here, it is just listing all the processes running. Okay, so who keeps track of all these programs? Again, your kernel. Okay, so kernel is the one behind. Okay, so which is keeping track of all these processes. Okay, so it's a long list of different programs which is running on your Linux machine. Okay, so this is about your software program management, how it is done. Okay, so next we'll see about hardware management. So we'll see about hardware management. Okay, so we have already talked about system memory management, and also we have talked about software program management in the kernel. Okay, so these are the four functions we have already said. Like we'll talk about hardware management. So there is always like another responsibility for the kernel, that is hardware. Okay, so how it is going to manage the hardware is always something which is dependent on the kernel. So any device which is on the Linux system must communicate with the driver code inside the kernel code. Okay, so whatever the device it is. Okay, so Linux system will be communicating with the, or it has to be communicate the driver code, okay, which is inserted in the kernel code. Okay, so this driver code will be within the kernel code, where any device which is connected will talk to this kernel code, and also this driver code will allow the kernel to pass the data. Okay, so whatever the data is coming, so it will allow that to pass the data to the device. Okay, so for example, if I have any device, so this driver code will help kernel to talk with the device, and also it will help to move data back and forth to that device. So it is always acting as a middleware component, or you can say something in between. Okay, so like your middleware components between your application and hardware, how it works. So in the same way, this driver codes or the kernel is behaving like a middleware component. And also there are two methods actually which is used to insert device drivers code into the Linux kernel. So what is those devices that what are the methods? So there are two methods. Okay, so which is used to insert device driver code. This driver code can be inserted into the kernel code using two methods, that is drivers compiled in the kernel and also drivers modules which are added to the kernel. So I just type them. Okay, so it is always your kernel code, right? So what is the method to insert your driver codes into kernel code? So say driver code. So we have two methods. Okay, so one is drivers compiled in the kernel, and another one is driver modules added to the kernel. Okay, so these are the two things where your hardware like your so driver code will be inserted to the kernel code. These are the two methods which will help you. Okay, so this is about your hardware. So whenever you are talking about hardware management, it has always required to have your driver code, and this is inserted into the kernel code using two methods, and this will help you to talk with the devices, or it is also helps to append your application, like to use your hardware for the application using the kernel. Okay, so this is very important. Next is a very important topic, that is file management. Okay, so file system management. So how file system management is a main function of the kernel. So when you are talking about some other operating systems, okay, so like Windows or any other operating system, Linux is the one which supports different types of file systems, like to read, write data from your hard drives. It supports different types of file systems. Whereas if you pick Windows, okay, so it will only supports few defined types, but kernel like Linux kernel is the one which supports different types. And also, like when I'm talking about different types, we have different types of file system. Like I'll give some examples like ext, ext2, there is ext3, ext4, and we have brfs, that is and we have xfat, and we have hpfs, and we have jfs, we have iso, we have minix is the one which is used in um, storage, like small storages, and you have ms, it will also support ms dos. There are so many like nfs and ufs and vfat. Okay, so like you name it, and there are so many file systems it supports. And also one more important thing is xfs. Okay, so these are all the file systems, and there are so many, like I have not mentioned all the file systems. I have mentioned only the ones which I remember. Okay, so generally, like whenever you are talking about file systems, so what is the main job it will do? Like you can read and write from the file systems using your operating systems. Okay, so whatever, like it might be your Linux kernel, it might be your Microsoft Windows, right? So this is very important, like how you boot your machine also, right? So when you are talking about ext is the one, you can call it as extended file system, which is now used, like ext4 is the one, there's the fourth extended file system, you can say, which also supports advanced journaling. Okay, so we'll see about all that stuff, but yeah, like right now most used is ext4. And also any hardware that a Linux system accesses must be formatted using any file system type. Okay, so any one of the file system types, you need to format your hard disk, then only you can use your hard drives. Okay, so that most of you guys know, because most of you guys also use Windows, because whenever you want to use some file system the disk, you need to format with a proper file system, otherwise you cannot use that hard drive. So the Linux kernel is the one which is an interface with each file system, like it will be using virtual file systems, which provides a standard interface. Okay, so this is the one which provides a standard interface for the kernel to communicate with any type of file system. Okay, so what is the interface of the file system in the kernel? That is VFS. Okay, so VFS is the interface. Okay, so this virtual file system will provide you the standard interface for the kernel to communicate with any type of file system. So whatever the file systems we have mentioned here, okay, so this will help to communicate with each other. Okay, so this is about your file systems and how kernel is defined within the file systems, or how it is being used. This is the structure. Okay, so this is about your Linux kernel. Okay, so lot of questions being asked for the Linux administrators. If you are on an advanced level, or if you are going for 4 to 5 years of experience, then some of the questions are being fired from Linux kernel also. So the reason why I've just wanted to give you an overview of Linux kernel. So this is about your Linux kernel. So you need to remember all the 4 main functions of the Linux kernel, so that if someone asks you like how kernel starts the process for switch process, and how it communicates with the hardware management, and how it is managing your memory, and how it is managing your file system. Okay, so you need to you can still go deep dive. Okay, so you can do a lot of deep dive in learning all this stuff. Okay, so you guys can go and check on them as well. So we'll see. Now we'll see what are the GNU utilities. Okay, so what do you mean by GNU utilities? So when you're talking about GNU utilities, we have seen like what kernel does, right? So it is the one which controls your hardware devices, and it is the one which launches your programs, or it is your computer operating system. Like all this comes into picture when you are talking about kernel. But how your operating system, like whenever there is something or you need a utility to perform standard functions, like you want to control your files. Okay, so you want to control the programs which are deployed on it. Okay, so when we are talking about GNU utilities, there are few of the GNU core util packages which are like utilities for handling files. Okay, so I'll just give that here. So utilities for handling your files, and there are utilities to manipulate your text, right? And also there will be utilities to manage your processes. Okay, so these all things has to be like, there should be some utilities to manage all this stuff. Okay, so there is something called GNU, so which is like you can say like GNU is full formed as GNU's not Unix. So this is something which was developed completely using Unix utilities. And also when we are combining the product of kernel and GNU, we are calling it as Linux. So combination of these two are making a full Linux operating system. So how this has come up again, when Linus Torvald was working on this core Linux kernel functionality, there was other group of people who were also developing this software philosophies, which is called as open operating softwares. Okay, so or open source softwares, that is called as OSS. So whenever there was a combination, like there is a concept of OSS allows programmers to develop software and then release it to the people, like into the open world. Okay, so there is no license for it, there is no license attached to it, like anyone can use that softwares. And also like you can incorporate that in your own system without having any license fees. So that is where when these Linux or Linux kernel and these GNUs came into the came into the picture, like combining with each other, then it has created a operating system utility like your free operating system called Linux. So that is where it has came into the picture. So it is like handling things properly with the utilities on your Linux. So how you handle files, how you manipulate your testing, and how you how you manipulate your text files, and also how you manipulate or manage your processes. Okay, so all these stuff comes into your GNU utilities. Then comes your Linux user interfaces. Okay, so what do you mean by Linux user interfaces? There are a lot of Linux user interfaces. Like for example, if I see, okay, so if I go back here, this is my Linux interface. I can say like it is my X Windows software. You can use graphical mode. You can use something called plasma desktops. Okay, so that is KDE. So which is called as plasma desktops, and we have um, genome desktop. Okay, so these are all the user interfaces which are being used. And also there are different types of desktops used in the Linux. And also there is something called Flubox, there's something called XFC, JWM, FVWM. There are a lot of user interfaces. And the other thing is your command line interface. So while having so many graphical desktops, let me open this. Okay, when you are talking about graphical interfaces, for example, if I go here, okay, so this is my graphical desktop. But when you are talking about command line, okay, so command line interface, like when we have a lot of graphical desktop interfaces, there are many drawbacks. The extra processing power is required to interact with your graphic cards, and the crucial CPU time, which is used to manage all your programs in this. Whenever you open your browser or you open some software on this. Okay, so there's a lot of memory or a lot of CPU being time is being used. So because of that, so many Linux servers don't have this graphical desktop concept. So instead they rely on this text-based interface, that is your CLI. Okay, so if I open my CLI, okay, so this is how it will be. The most of the people are using CLIs. Like all your Linux servers, not most of the people. So all of your Linux servers are being on the text-based interfaces, that is command line interface. There is no graphical desktops being deployed on any Linux servers. There is only Linux desktops which will have all your user interfaces like Genome and all KDEs. Okay, so but when you are talking about Linux servers in the real time, you will see this interface only, that is your command line interface, and this is the one which provides a way for users to start programs and manage files on the file system, manage processes running on the Linux system, and also it will use simple text commands like what I am using. Okay, so if I want to use some simple, like if I say clear, it just clears. If I go back, it just go back. I'll say free, how much memory is free. I'll see how much disk is available. Okay, so these are like we are just starting or whatever. If you want to start, you can start your programs, you can manage your files, you can manage your process running on the Linux machine with all these simple commands. And also this is and also this CLI is produced by a program. So how this program is running, how this all happening, this is the program which called as shell. Okay, so what is a shell? Shell is nothing but which will allow you to enter these text commands and then interprets the commands and then executes them in the kernel. Okay, so where it is going to execute all these commands are executed in the kernel, and this is where we call it as a shell prompt. Okay, so the CLI which is produced, okay, so like whatever the command line interface, whatever we are doing, okay, so this is the program name is called as shell, and this shell is the one which allows you to enter all these commands, and also it interprets the commands. Then all your commands, whatever, like for example, if I have ran df-h, where this is executing, this is executing on the or in the kernel. Okay, so this is executed in the kernel. Okay, so that is the reason why whenever we are talking about shell, okay, so let me go back here. Okay, so whenever we are talking about shell, okay, so shell is the one which contains set of internal commands. So it will have all set of internal commands. Whenever you want to control things, like you want to copy the files, you want to move your files, you want to rename your files, you want to display the program which is currently running, you want to display the process which is currently running, and you want to stop some programs, you want to run the programs on the system. So all these been like all this is with the shell which is having internal commands, and also beside these internal commands, shell also allows you to enter the name of the program. Like for example, the shell passes the program name off to the kernel to start it. So if I say something like systemctl start the program name, so it just started program within the like inside of the kernel with the name of the program. And also there are few Linux shells available on Linux system. This question been asked by a lot of people, but different shells have different characteristics. Some are more useful for creating scripts, and some are more useful for managing your processes. But the default shell used in the Linux distribution is bash. Okay, so default program shell which is used in the Linux distribution, most of the Linux distributions, is bash. Okay, so
what do you mean by bash? And also this is again a GNU project, which is also a replacement for the standard Unix shell, that is Bourne shell. Okay, so there is something called Bourne shell. Okay, so this is a replacement of the Bourne shell. The bash is the one which is being named after Bourne shell, that is born again shell. Bourne means Bourne. Okay, born again shell. Okay, so BASH, bash. So that is the name, we call it as bash. So what are the shells we have in the Linux? Different Linux shells. One is ASH shell, we can say corn shell, TCSH, and ZSH. ZSH is also one of the used shell. I think Mac is using ZSH. Okay, so this is advanced shell actually that incorporates features from bash. It will incorporate features from TCSH, and also this is incorporating from corn. Okay, so it's like a combination of all these three: bash, TCSH, and corn shells. And also it provides advanced programming features like shared history files, theme prompts. Okay, so these all being used in the ZSH. So every shell has its own characteristics. Okay, so and each shell has its different characteristics. So most Linux distributions include more than one shell. Even you have a default like bash, and if you are using Linux distribution which have like you can install your shells also. For example, if I say sh, okay, so it is when move me to the Bourne shell. Like if I say tsh, I'm not sure if tsh is available. So tcsh. Okay, so now I'm into the tcsh. So if I want to go to ASH, okay, ASH is not available. If I say corn is also not available. If I say bash, it will be moved to the default bash shell. Okay, and also I can check on which shell I am working on. For example, if I say tcsh, okay, and if I run something with this command, okay, so it says like bin bash, or if I go with sh, okay, if you see here, it's totally different. Okay, so what is happening here? Okay, so SHL have different commands, and when I come back, it will show what else I'm running in a different shell. For example, if I do SHELL, okay, so it says bin bash. Okay, so all my shells are been in the bin bash, and also if you see, if I come back of it, if I say exit, it is coming out of that shell, nothing but I'm into that shell. And if I say exit, again I have came out of tcsh, I have came out of sh. Okay, so now I came into the sh, I came out of sh. So this many times I have entered into the different uh, shells. Okay, so this is how you can go into the different shells. If you want to work on different shells, you can go and work on the different shells as per their characteristics. Okay, so we'll talk about the Linux distributors. Okay, so we have talked like we are talking about shells, but now we are also talking about a lot of Linux distributions. Okay, so what are the Linux distributions we have? So we have different Linux distributions which are divided into two categories, that is core Linux distributions and specialized distributions. So these are the two distributions which are being majorly divided. When you are talking about core Linux distribution, which contains a kernel, one or more graphical desktop environments, and also just about every Linux application that is available with the pre-compiled for the kernel. So for example, if I say Red Hat Enterprise, which is a commercial business distribution used mainly for internet servers. Then we have something called Debian. We have something called OpenShift. Okay, so let me give the distributions. Okay, so for example, if I say Slackware, and we have Red Hat Enterprise. we have Gentoo, we have OpenSUSE, we have Debian. Okay, so these are like um, different types of distributions in the core Linux distributions. And also, like I said, we have something called specialized Linux distributions. So specialized Linux distributions are nothing but these are the new subgroup of the Linux distributions which have like typically based on one of the main distributions, but it will contain only subset of applications. What I mean is like whenever we are talking about specialized Linux distributions, like you can also, in addition to provide the softwares like Office or such as only Office products for business users or customized Linux distributions, and you can have your Linux user, or you can begin Linux users by auto detecting and auto configuring common hardware devices. These makes installing Linux a much more easier way. Nothing but it's like your traditional way of installing the Linux Windows. Okay, so if you want to update any software, or if you want to connect any device, for example, I have connected a device on my mobile phone or my writing pad or my pen drive, it should auto detect or it should auto configure. So when you're talking about core Linux distributors, they don't do that. But when you're talking about specialized Linux distributors, these are all the distributors which work on this kind of stuff. The one which is extensively used nowadays is Ubuntu. And also we have MX. Okay, we have MX Linux, we have Mint, and we have Fedora. Okay, so Fedora is also one which is a free distribution, and which is generally used on testing Red Hat Enterprise Linuxes. Okay, and also Ubuntu is also a free distribution. This is also, initially these guys have created Ubuntu to give home desktops or to use it for schools. Okay, so the purpose, like the initial purpose of the Ubuntu was that, but now there are huge number of servers being also used in the organization. Now when Ubuntu server came into the picture, people are started using that also in the real times. MX also, it's a free distribution. This is only for your home use, like how you use your Windows desktops. Okay, so next is your Linux Mint. Linux Mint also a few free distribution, but it is more on entertainment use. Okay, so you can try Linux Mint if possible on your local machine, and you can use it extensively because it's a free distribution. Then we have something uh, distribution, like there are few distributions which are also coming up recently. Okay, so you can check all those distributions, like how it is there and how it is been coming up and what are the characteristics of those distributions. Okay, but these are all not much important when we are talking about real time. Okay, so when you're talking about real time, it's always Red Hat or Ubuntu and OpenSUSE. These three are being uh, coming up, or these three distributors which are being heard mostly. Okay, so when you are talking about real time, Red Hat is the one which is being used, like 60 to 70% of the servers are running on Red Hat. When I see within within India, okay, so I'm not talking about outside of India, but when you're talking about within India, what we are managing in the real time, what you will get when you are going into the organizations, that will be mostly your Red Hat. Okay, so this is about your basics of Linux. Okay, so how the basic functions works and how the basic behavior of the Linux, or you can say that this is the understanding of basics for the Linux. Okay, so I'm not going to talk about installations as such, because most of the time, like we have all that been done already. Okay, so done already in the sense not in our channel, but there are so many channels which talk about installation of the servers. Okay, so like if you want to install a VM, you can get that VM, install that. Okay, so I'm not going to talk about that, but I'll just give you an overview of how you can go for the practice. So it is always better you go with your virtual machine or a virtual box. Okay, so go for the virtual box or virtual machine. If you see like you don't have much configuration on your physical machine, that is your laptop or on your desktop, go for AWS or Azure or GCP. You have so many cloud distributors, okay, or you can say cloud providers. So there are so many cloud providers where you can go and launch Linux machines. You can launch Red Hat, you can launch Ubuntu. Okay, you can launch any one of the servers and you can practice on these machines as well. Okay, so when you are talking, when we are doing session or when we are doing complete session on Linux, like mastering of Linux, we'll talk about installations on CentOS, like on your Red Hat machine, and also we'll talk about installations on Ubuntu. So I will make two pieces of VMs. Okay, so one which is already been running, okay, so in the background, that is my uh, CentOS server. I'm also going to launch my Ubuntu server. So we'll see how we can differentiate between these two and how we can work in with the installations between these two. And also after that we'll see like we'll go forward like exploring our working with file systems, working with text files, then how you manage, how you booting items in Linux, how you work with your storage devices, network devices. Okay, so we'll try to cover all that stuff going forward. Okay, so I'm not going to talk about installations as such. Okay, so you guys can go and install your Ubuntu or you can install your Red Hat. Okay, so after that we'll go and check like how you will install and maintain these softwares in these providers. Then we'll also check on how we can work on basic shell. Okay, so what are the basic shell commands, how we can work on shell. Okay, so after that only we will move forward to Linux file systems or the text files, all that stuff. Okay, so these are the two important things you guys need to do for the next session. Install your Ubuntu or install your CentOS or launch your Red Hat or install your Red Hat on VMs or clouds. Okay, so this is it for this session, guys. Hope you guys have enjoyed. You guys know, like, got to know some of Linux at least. Okay, so thanks for watching this video and have a great day. Bye.